Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to draw electric field vectors. So what we're looking at, I've got three charges here that we're going to consider to be point charges. I've got a plus Q in the lower left corner, another plus Q over on the right, and a minus Q on the upper left. And again, I like to color code my charges. I generally use reds for positive charges and greens to show negative charges. And there's nothing, the charge doesn't have a color associated with it. I can't overstress that enough. I could just as easily made this one red or this one green and this one red, but I just like to visually be able to see the differences in the charges. What we're going to do here, I've already put a dot at this point, is I'm just going to talk about how to draw the electric field vectors at this point in space due to these charges. Now, there's nothing special about this point in space. I just picked a point that I thought would be a nice point to start with. I think before I end the video, I'll probably pick a couple other points and go through some examples. But what I'm going to do now is just talk about how to draw the electric field vectors due to each of these charges at this point. Now I'm going to go ahead and give these points charges names so that I can refer to them. I'm going to call this one charge 1, and this one charge 2, and this one charge 3. Now, in this example, we're going to imagine that these charges all have the same magnitude, Q, Q, and Q, other than this one's negative. All right, so let's start drawing electric field vectors. I think I'll start with this one. So again, the electric field direction is defined as the direction, defined as the force direction on a small positive test charge. So if I imagine putting a proton right here, and again, that's just a point in space, that dot's just representing a set of coordinates, but I imagine putting a small positive charge here. These two charges would repel, so the force direction will be up. Therefore, that is the electric field direction at that point due to this charge. I'm going to go ahead and put a 3 on it because that's the electric field created by charge 3. Now, as far as how long do you draw the vector, well, that's completely arbitrary. You can draw that vector any length you want. Now that I've drawn that vector, however, I'm going to try to at least scale the rest of the problem with respect to this one. All right, let's talk about this guy now. This guy, again, is positively charged. So I imagine now putting a small positive test charge right here. These two charges would repel. Therefore, the force direction on this small positive test charge would be up and right. Therefore, the electric field vector at that point looks something like this. Now, let's talk magnitudes. These are the same charges, and this is quite a bit more distance than this. So this electric field vector is going to be quite a bit shorter. So I'm going to go back and shorten it up. Now I'm not going to worry right now about how much shorter. For now, I'll just shorten it to about maybe this. And again, I'll make another video about that shows magnitudes in a little more detail here. So I'm going to go ahead and call that one E2. So there's the electric field vector due to charge 2. And again, it's smaller than the electric field due to charge 3 because they're the same charges, but this one's quite a bit further away. All right, next, let's talk about charge 1. So if I put a small positive charge here, this charge will attract it. Therefore, the electric field vector at this point due to charge 1 is to the left. I'll start with something like that. I'm going to call that E1 for now. All right, now I'm going to talk about magnitudes a little bit. This one is the closest charge. This one is the furthest charge. So this distance is less than this distance, but more than this distance. So this vector is going to be somewhere in magnitude between these two. So I'm going to go back and maybe do something like, oh, maybe not that much. Maybe something like that. That's good enough. And again, I'll make other videos that are a bit more exact as far as how long those vectors go. But, well, there it is, folks. There are 3 electric field vectors, E1 due to charge 1, E2 due to charge 2, E3 due to charge 3. And I'm not going to calculate or do any calculations in this video because my hope here was just to help people learn how to draw the electric field vectors. But to do the calculations, we would need these charges and we would need these distances. And again, this is meant to be a conceptual video. I think before I go here, I'm going to pick another spot here and go through another example. So let's talk about maybe this point right here. And let's say it's halfway between these two. So the electric field vector due to charge, let's talk about charge 2 first. I imagine putting, it's not quite in the middle there, but there, we'll imagine that point right there. So imagine putting a proton right here. This animal will repel it, so the force on that proton is to the right, and therefore that's the electric field direction due to this charge. So let's call that E2. Now, I did not intend, like the length of this vector, there's no reason to leave this off right on the end here. That was just kind of coincidence. I was thinking about the magnitude, taking note that this distance is just a little shorter than this. So I was trying to draw that vector just a little larger. Maybe I could have drawn it even a little bit further, but I just want to point out, the distance from here to here physically is not the electric field magnitude. There's no reason for this vector to end here. I'm going to go ahead and leave it in the picture, but I just want to make sure that was not misleading. Let's talk about this guy. So the electric field at this point, due to this charge, would point to the left. And it would be the same magnitude as the first one. So I'm going to go ahead and call that one E3. And again, it's just coincidence. I didn't mean to imply that that vector should be drawn and end at that charge or anything. I was just trying to draw these two vectors just a little longer than this one. Actually, I probably should lengthen both of them, but anyway, let me get the last one drawn. The electric field at this point due to this charge, and again, imagine putting a small positive test charge here. This guy will attract it. So that electric field vector will point this way. I'll call that one E1. And again, this electric field would be quite a bit shorter than these two because this distance is a little bit further. So I think that's enough for this video. Again, the intention here is just to conceptually be able to determine the electric field direction around a bunch of charges. So I hope this video helps demonstrate those concepts. Have a great day.